Okay, so I'm gonna make a new video about how to just Canadian compile LLVM. But first we need to do is we need to to natively compile LLVM. Really unfortunate, I just make a video about that, but it's really unfortunate, okay? Because after I compile that, it has no sound. Okay, it has no sound. I have to recreate this video. Recreate the video. So what we're going to do is that we create a directory called llvm build. Okay, so then we're going to make you for example. Then what we're going to do is that we use cmake. Okay, cmake here. llvm and we build shared libs. Okay. So depends on whether you have clan or installed. If you do have clan LLD whatever installed, you just do. If you don't have that, you just use GCC. Okay, this cmake C compiler, GCC, XX compiler, G++. Then on. Okay, build a share libs like goes on. The other thing we need to put here is we need to put the llvm enable projects. We need to put three things here: lldb, clang-tools-extra. Right. So the first one is clang. The other is second is LLD, then it's lldb and clang-tools-extra, which is things like client ID or client format or whatever. So you can just ignore this part, okay? You can just ignore this part. Just build LLD is fine, but we usually just build one. Now we also need to do is enable llvm enable runtimes. llvm enable runtimes, which is a new tower since which is client 14 or client 13 here. Yeah, enable runtimes. So we only build compiler RT. You can just building things like llvm whatever. But I'm not going to use llvm. Okay, I'm not going to build libcxx. Okay. So since I have already compiled clan, I can just, if you have done the things like I do, you can just add the thing here, right? Add the thing here. We just do that here, copy here. Okay. So not GCC but clan. Okay, but clan. Okay, we need to change our compiler to clan. Then when we do this, we need to put this part here. Okay, enable link error thing L2 and LLD whatever. Okay. So what you can do is that we should just frequently just pour llvm, right, to get an upgrade. Because llvm updates more frequent than GCC. Right. Statistically, sometimes it doesn't. Right. So Ninja. Okay, I have already do that. I've said I've already done that before. That's why it compiles very fast. It looks like compiled very fast because I just in my previous video it has no sound. This problem has no sound. Let me test the microphone again. Okay. Sound statistics. Microphone. Okay, it works. Right, it works right now. Yeah. Okay, we need to build the clang-tools-extra. Client ID. You can see client ID, clan. Like clan format, whatever. Thing LTO. See, it's just, I should say here, if you don't have clan installed, you just do this, okay? If you have clang installed, then you don't use LTO anymore. You're just using clang and clang++, right? It doesn't matter. Just check the settings here. I just make things worse. Okay. Yeah. Should not have any system sound, so I can play some music while recording the video here. Or just YouTube will they're just saying you are violating their copyrights for the music, whatever. I'm not going to do that. Just do something, whatever. 测试没？Test microphone. Actually, the linking process will be very slow because we're using thin right? This linking will probably take a lot of time than compilation. But it's still quite fast because they will duplicate ODR violating or violation things here. What? Just will upgrade this hash. This happens when I did not do anything, right? Whatever. I think it's probably runtime issues. Okay. or you need to build runtime, you don't have one. You really need to build a compiler RT, or it won't work. Okay. The only thing you need to build is always compiler RT. Anything else doesn't matter. Okay, it's LLDB's problem, not the problems of things. It's not the problem. It's that I just recompile things, right? Which is, since I want to save everyone's time, I don't want to reconfigure again. Collaborating. Why is double clash, right? Whatever. Just we have assume we have done that. Okay, we just do install install script. Okay, install something like this, but we haven't compiled compilation. It won't be able to install. Okay, no problem. So there's another thing we need to install is llvm, right? Let me see whether my microphone is set up. Okay, so there's a thing that which is not installed, which is llvm. You can see there are 3 llvm, LL table. You can link all of them. Llvm, 3 llvm, clang llvm, lldb llvm, and llvm llvm. They are not installed. So the correct way to do that is that we strip unneeded clang llvm, LT, all the llvm here. Okay, then we sudo cp all the llvm to usr local bin. Okay, so now we have clang llvm, which okay, we have all the llvm here. Then we can just try to compile the things with llvm. Okay, compile it. Now we can see it's done, right? It's using our GCC we built today, yesterday. We can also just, the things quite different from clang and GCC is that GCC's clang itself is also a cross compiler. Okay, so if you have already installed the target compiler RT, you will be able to do this. Okay, for example, we have already the GC cross compiler we built yesterday, or we can just using Canadian compiler, whatever. It doesn't matter. It just try to find libraries. It doesn't matter which library it tries to find. Since cross and the same, we will be able to just using the libs from GCC to compile the thing here. Yeah. You see here we have, right? This is yesterday GCC, but on Windows. So you can see clang itself is a cross compiler. That's what I mean. You can set target, which is not what GCC could do. GCC you need to say a triplet, right? x86-64, min-GW, GCC, but clang doesn't work that way. Clang target is equals to that triplet. Okay. Now we can just try, for example, Linux AX64 Linux kernel. Then we go cross whatever. Go to our. We probably be able to do that, but you probably cannot just direct to that because we haven't built compiler RT, right? So in the next video we're gonna show how to build, how to correctly do the thing here, but we'll have several videos on explain the thing. Okay, so now we compile AX64 Linux kernel program while using clang. Now you can see it's using the GCC library, right? Which is exactly the point. Okay, even you want to use clang for cross compilation, you still need to build GCC cross compiler first. Okay, that's why I'm recommending you to always build GCC first. It's because of that reason. Okay, that's about video about native compilation. The next video we're gonna explain how to Canadian compile LVM from Linux to Windows. But there are several things we have to do first, okay? Which is probably going to repeat our work before for several reasons. Okay, let me just explain in the next video. Check the microphone. Yeah, no problem. I hope microphone won't have any issues.